Today we'll discuss about network address translation, popularly known as NAT, which was a wonderful invention which helped in prolonging the lifespan of IPv4 addresses. NAT has been designed keeping in view of the IP address depletion, so it has helped in conserving the IPv4 address space. Now NAT allows a single device, mostly a router, to act as an agent between the internet, which is a public network, and a local network, which is a private network. While discussing about the IPv4 addresses, we have seen that there exist many private IP addresses in each of these classes, which are allowed to be used by private individuals in their private networks without buying those IP addresses. Now, say an organization has created a network and it has allocated private IP addresses to this host. Now, this NAT, the network address translation, is basically a device, a router mostly, which acts as an agent between this private network and the internet as a whole. So we have an internet at the other side of this router and the private network at the other end of this router. So this is an interface between this private network and this public network. So this allows that a unique IP address is sufficient to represent this entire group of network. That means we'll later on see that how a single IP address, by buying a single IP address, one can ensure that all these computers of this network is capable of accessing the internet. Apart from IP address conservation, NAT also provides security. We'll see how does it provide security. Now, the first commercially viable NAT device was conceived in the year 1992 by this person, John Mays. He, along with Brandley Coley, created the first commercially viable device, and then they created an organization which was known as NTI, which was later acquired by Cisco. Now, the concept of NAT is very clear. It allows a single device, mostly a router, to act as an internet gateway for internal LAN clients by translating the client's internal network IP addresses into the IP address of the NAT-enabled gateway device. Now, what is the meaning of this? The meaning is simply, we have already said that at one end, this is a private network and there are many computers, and each of these computers has been allocated a private IP address. Now, this intermediate device, which we are calling as a NAT device, what it does is basically the organization has to buy certain public IP addresses, because private IP addresses cannot be used in the internet. So it either buys one public IP address or two or some amount of public IP addresses. Now, what the concept of NAT is that this particular gateway, what it will help to do is it will help to translate the IP addresses of this private device into the corresponding public IP addresses. Why? Because first of all, these private IP addresses cannot be used in the internet. So this helps to map these private IP addresses to that particular public IP addresses, because only then the public IP addresses is capable of accessing the internet. We'll see how a single public IP address, by buying a single public IP address, one is capable of mapping a huge number of private IP addresses. Say I have around 1,000 computers, and each of these computers allotted a private IP address, and using this concept of NAT, it is possible to map these 1,000 computers, these 1,000 private IP addresses to a single public IP address. And this is how IP addresses are saved or conserved. Clear? Now, NAT runs on this device that is connected to the internet. So this is the device, the intermediate device, which is connected to the internet and hides the rest of the network from the public. So this side, this local side, this private side is hidden from the internet, and thus making the whole network appear as one device or computer to the rest of the world. That means internally these are your computers, and this is your intermediate mapping device, the single device, the gateway, which is working as the NAT device. So for the other world, for the entire world, for the internet, they will not see this internal structure. They will simply see this device. They will simply see that this is your organization which consists of this particular device. The other end is hidden from the internet. Okay, and NAT is transparent to your network. It means that once you use a NAT device, you are not required to reconfigure these internal devices in order that they are able to access the internet. And NAT is secure because it hides your network from the internet. The internet cannot view your internal network. It can only view the NAT device. So NAT makes your network secure. So all communication from your private network are handled by this NAT device, which allows that the appropriate mappings takes place between the private IP address and public IP addresses. Now remember, though we are saying that NAT maps a public IP address with a private IP address, NAT is not only used for such a task, it can also be used between different private networks. So it is not necessary that always there is one private side and one is the public side. NAT can happen between two public sides as well. Now let's understand the NAT concept with this particular image. Now say this is your network and you have these are your computers. These are your computers. You have connected many computers in your network and you have assigned a private IP addresses to these networks. We already know what a private IP address is. If you do not know what a private IP address is, I advise you to go back to the IPv4 addressing scheme. There we have already discussed what are private IP addresses. So this is your network and you have your computers connected, and each of these computers have been provided with a private IPv4 address. Now you use a device. This NAT device is basically a router, NAT enabled router, and then you buy a say public IP address. This is a public IP address, so only this address can be used in the internet. So what is your NAT device doing? It will map this private IP address to this public IP address. That means whenever some data is going from your network to the internet will not see these IP addresses. It will only see this particular IP address. And whenever some messages are coming from the internet to your network, those messages are not using these IP addresses. These IP addresses are hidden. Basically, they cannot be used in the internet. The outside world only sees this public IP address, so every message will be sent to this destination. It is a task of this intermediate router to deliver the message to the appropriate computer from where the original message was destined to the other world. Clear? So this is a mapping device which will segregate this private network from this public internet. And this is how the internet actually sees your network. For the internet, for the outside world, this is your network. It has got this public IP address. Okay, going back to the previous image. So this is your public IP address, and for the outside world, this is your network. It does not see the internal structure of your network. Now at the heart of the NAT operation is a table known as the NAT table. Now since we are talking that there is a mapping between a private IP address and a public IP address. Basically it's a mapping between two addresses. So when we talk about mapping, obviously there should be some information, and that information should contain that at one side there is some private IP address and at the other side there is some public IP address, and this particular private IP address is mapped to this particular public IP address. Clear? Because it's a mapping. Apparently it's a mapping between one side of addresses to the other side of addresses. So because there is a mapping, we need to have an information, and that information is kept in a table. That table is popularly known as a NAT table. So this NAT table will be managed and created at the intermediate device, the NAT enabled routers. So this NAT table is what allows the devices on a private network to access the public network. That means apparently the main task of NAT, that the private IP addresses are capable of accessing the internet using the public IP addresses. This is made capable by using this particular NAT table. We'll see that the NAT table the structure of this NAT table varies according to NAT modes. There are basically 3 NAT modes, and these are the 3 NAT modes. There is a static NAT, there is a dynamic NAT, and there is another mode which is known as NAT with PAT. PAT stands for port address translation. This is also popularly known as NAT overload. We'll discuss each of these 3 modes one by one right now. And the first mode is known as static NAT. As the name indicates, it's a static mapping, a fixed mapping. So it's first of all, it's a one-to-one mapping. That means one private IP address will map with one public IP address. So this is a one-to-one mapping between a local private address and public addresses. For in this example, I have a network which say these are my computers, and each of these computers have a private IP address. And then I have 3 public IP addresses as well. So I have 3 private addresses and I have 3 public addresses. So each of these public addresses is mapped to a dedicated public IP address. So this private IP address maps with this public address, this private address maps with this public IP address, this private IP address maps with this public IP addresses. So apparently, if I have 1000 computers, in my private network, in that case I require 1000 public IP addresses. So you may say that this does not conserve any IP addresses. If I have to buy 1000 IP addresses, if I am using 1000 public IP addresses, why not I use directly those addresses in my private network as well? So apparently, obviously, static network will not help in conserving IP addresses, but static net will help in providing privacy. That means because the outside world does not see these internal addresses, so I can hide my network, I can hide my internal details, and instead I use the public IP addresses and save my internal network from any interference from the outside world. For example, the different web servers which are installed, they may use internally some private IP address and then use a NAT device to show the outer world a public IP address. Now let us see how static net works. Say this is my internal network and this is one computer of my internal network, and this has got a private IP address 10.0.0.100. So this particular address is a private address, and now I have this router, this NAT enabled router, and I have a public IP address as well. So this particular private IP address, say 10.0.0.100, this is my private IP address. Now say I have a public IP address, and this private IP address is mapped with that public IP address. So say the public IP address is something like, say, 101.7.0.1. Just an example. So what will be there in my NAT table? So I have a NAT table where there are simply 2 entries. One is the private IP address and the other is the public IP address. So I have simply 2 entries in my NAT table. So in my private IP address, I have the private IP address 10.0.0.100, and it maps to the public IP address, which is 101.7.0.1. Clear? So if I have some more private IP address, so there is another private IP address which will map to another public IP address. So for each of the private IP address, I require to have a public IP address. Now say this particular host sends a message to a web server. Say this is a web server in the internet. Some web server, say www.abc.com, any web server, and this is the IP address of this web server, 155.4.12.5. Remember, this is a public IP address. Anything on the internet should have a public IP address. Now say a message goes from this host A to this web server. So now because it's a web server, this will be listening on port number 80, obviously. And say this is using, this particular host is using a random port number. The source port number is, say, 7000. Just for an example, let's use any port number. Say this is using the source port as 7000. Now what is the message? When the message goes from A to B, what is the source IP address? The source IP address is 10 0 0 100, and the source port number is 7000. Clear? So the destination IP address is 155.4.12.5 and the destination port number is 80. Clear? So the message has been created in host A, and first the message comes to this router. Okay. Now this router will look at its NAT table, and what it will do, it will simply change the source IP address in that particular packet and change the source IP address to this public IP address. So it will change the source IP address to 101.701. Clear? The source port remains same, the destination IP remains same, 155.4.12.5, and the destination port also remains same. Everything else remains same except that the source IP has been changed from the private IP address to the public IP address. From where does it get this information? It gets the information from the NAT table. Okay. Now the message goes to this web server. Now this web server will create a reply and send back. So in that reply, the source IP will be this IP. Things will be reversed. The source IP will be 155.4.12.5 and the destination IP would be 101.701. And source port will be 80, destination port will be 7000, and that packet comes to this router. Now remember, the destination IP address was this public IP address. Now actually it has to be sent to this machine. So what it will again do, it will simply change the destination IP address from 101.701 to the destination 10.0.0.100. This is 10.0.0.100. Clear? How does it do it? It does it by looking at this NAT table simply. So this is how static NAT works. Simply there is a mapping between a private IP and a public IP, and that NAT device, the intermediate NAT enabled router, will simply change the private to public and public to private, where private to public whenever a message is going from the private network to the public network, and from public to private whenever a message is coming from the public internet to the internal network. Clear? So this is how static NAT works. The next type of NAT is known as dynamic NAT. Now this dynamic NAT is also a one-to-one mapping. That means one private IP address will be mapped to a public IP address. The only difference between static NAT and dynamic NAT is that this mapping is not static, that is, it is not fixed. In the previous example, in the static NAT, the mapping between that private IP and the public IP is fixed. It is fixed for every time. Whereas in dynamic NAT, if a public IP is mapped with a private IP in one session, it is possible that in a subsequent session that private IP address maps with a different public IP address. That means the mapping is not fixed, it is dynamic depending on the timing. So say this is an example. Say I have bought, this organization have bought 3 public IP addresses. Public IP address 54.5.4.1, 4.2 and 4.3. So there are 3 public IP addresses available with this network, and then it has this internal network where there are many computers. So in this example I have shown 4 computers. So there are 4 computers, and each of them have been assigned with a private IP address. So this is assigned a private IP address 10.7.7.71, this is 72, this is 73, this is 74. Now this is the NAT table. So as of now, this particular private IP address is mapped to this particular public IP address. This second one is mapped with this second public IP address. The third one is mapped with this third IP address. So this is again a one-to-one mapping. The only difference with static NAT is that this is not static or fixed. That means this particular mapping, say example this mapping, that 10.7.7.71 is mapped to 54.5.4.1. this mapping is not fixed. That means at some other time it may happen that 10.7.71 is mapped with 54.5.4.3. Clear? So there will be one-to-one mapping, but this mapping is dynamic. So in this example, now there is a 4th computer which tries to access the outside world. But because I have only 3 public IP address, these 3 are already mapped to 3 private IP address. So as of now, this cannot connect to the internet because no public IP addresses are available as of now. So if any one of them finishes their work and this mapping is over, then only this particular IP address can map to that public IP address. Clear? So the other things remain same. Whenever this machine say sends some machine to send some message to outside world, this changes would be same as the static NAT. What happens only that the source IP address, the source private IP address is changed to the private IP address from this particular mapping. Clear? So the working of static NAT and dynamic NAT is almost similar. The process is almost similar. It's also a one-to-one mapping. The only difference is that in the previous one it's a fixed mapping. In this example, it's a dynamic mapping. Now this is a scenario, an example where dynamic NAT can be used. Say, and in this example, I am not using the public network at all. I am showing the connection between two private networks. So at the beginning, we have said that NAT is not always that it is between the private and public. NAT can happen also between two public enterprises. So say this is one organization, this particular site, and this organization has a machine which has a public IP address, say 192.168.55, and assume that this is a coding server. That means here coding is done by different developers. So internally developers will log into this machine and do their coding work. Now say this organization has some tie-up with another organization. So this is another organization, and then some people, some coders of this organization can access this particular machine. Okay, some of the people are working on this machine. So say this organization have many networks. This is one network, this is another network, this is another network. So say there internally there are 3 sub networks, and only this network which has this organization structure 192.168.20, only people from this network can access this particular machine. There's a firewall installed which will ensure that only IP addresses of this range can access this machine. If you look at this IP address, 24 bits are used for the network. That means 8 bits are available for the host part. So 2 to the power 8. 2 to the power 8 minus 2 computers can be there in this network. Remember this we have already discussed in IPv4 addressing scheme. So this is a network where 2 to the power 8 minus 2 computers are connected, and only these computers can access this particular machine. These other networks, these other sub-networks of this organization cannot access this particular server. Now say this organization changes their structure, or they have expanded. Okay, so what they have done is they have created another network with this address range 192.168.80. Okay, now they have internally restructured, and they now shifted some of these people from this network to this network. Clear? Some of the people working in this network to this network. Now obviously they want that the people working in this network are also capable of accessing this particular server. Clear? Now remember, this firewall ensures that only computers of this network are allowed to access this server. So because this other organization has created another network which has a different structure 192.168.80, it only allows 192.168.20. This type of IP address it will allow. It will not allow IP address of this type 192.168.80. This. So there are 2 ways. First way is one can change the settings at this firewall. Now remember, this firewall belongs to this organization, and this organization does not want to ask the other organization to change their settings in their firewall. So what they do, they want to do something internally in their own network, so that people from this network are also capable of accessing this server. Now what can you do? Can you think of a solution using dynamic NAT so that this particular network is also capable of accessing this server. Think for a moment and then think what solution can be done. So an obvious solution is to use dynamic NAT between these two particular network, this particular network and this particular network. How? Install a dynamic NAT enabled device between these two networks. Okay, so this is one side and this is one side. Then allocate some of the IP addresses. How many IP addresses are available here? Here 2 to the power 8, because 8 bits are available for the hotspot. 2 to the power 8 minus 2, this number of IP addresses are available in this block. So from this IP address, some of the IP addresses are made available for this as well. So what it will do is, it will create a NAT table. It will dynamically map between these IP addresses of this network with IP addresses of this network. So if I have this IP address, say 192.168.81, this is the first computer which has the IP address 192.168.81, and this maps with an IP address of this network 192.168.20, say 20.10. So there is a mapping between 192.168.2010 and 192.168.81. So after this mapping, whenever a message goes to the other end, from here to the other end, obviously it will change the IP address from this IP address to this IP address of this network. So further, when it goes to the other side, it will look as if the message is coming from an IP address of this network and not an IP address of this particular network. So this is how a dynamic NAT has been used in this particular scenario to solve a particular problem. And then we go to the final mode, NAT with path. This is also popularly known by other names such as NAT overload. It is also known by the name NAPT, and it is also known by the name IP masquerading. Now this is the most popular NAT mode ever used. Static NAT and dynamic NAT is very rarely used these days. Now this mode, NAT with path, enables that a huge number of private IP address can be mapped to as only single public IP address. In the other examples, we have seen that you require that number of public IP address as that number of private IP addresses. If I have 10 private IP addresses, I require 10 public IP addresses also to map. Now in NAT with path, I can buy a single IP address and then map the single IP address with multiple private IP addresses. We'll see how this is done. Now, so this NAT with path in this many local private IP addresses can be translated to even a single public IP addresses. Okay, so how does it do it? It uses port numbers. That's why this is the name PAT, port address translation. This uses the port numbers to distinguish between the traffic. We'll see how it is done. So this is the most frequently used mode, as we have already discussed. It is also cost effective because the organization needs to buy only one single public IP address, and that single public IP address can be used to map between thousands of private IP addresses, so that those private IP addresses can access the internet using only a single public IP addresses. Now we'll see how this is done. Now first, this is an example. Say this is my NAT enabled router and I buy only a single public IP address. I have only one single public IP address, and then I have my multiple private IP address machines. So this is my private network, and each of these private IP addresses will map to this one single public IP addresses. What happened in static and dynamic NAT, that each of these private IP addresses needs a separate public IP address to map with. So this would require different public IP, this would require different public IP, this would require different public IP. But in this mode, NAT with path, all of them can be mapped with one single public IP addresses. Now how this will work? Now let's see our first solution, and then we'll see whether this solution will work or not. So now say I have bought a single public IP address. The single public IP address is 70.10.01, only one public IP address, and this is my intermediate routers. Now say I have these four computers in my private network, and these are the IP addresses. These are private IP addresses: 10.0.0.5, 10.0.0.6, 10.0.0.9, and 10.0.0.15. Okay, there would be a dot here. So 10.0.0.5, 10.0.0.6, 10.0.0.9, and 10.0.0.15. I have shown 4 computers. I can have many. So all of them map to one public IP address. Now say, let's take the example where this particular computer sends a request to a machine, say this particular machine, 100.0.0.1. I have a machine at the outside world. Say this is a web server. This is a web server whose IP address is 10.0.0.1. Clear? Say this is a web server, and because it's a web server, it is listening on port number 80. Clear? So this machine sends a request to this machine, and assume that it is using the source port as 2311. So it is sending a request to 100.0.0.1. This is the web server. It is listening on port number 80, and this machine with the source IP address is 10.0.0.5, and say it is using the source port 2311. It is sending a request. Assume that another machine with another IP address obviously is sending a request to that same web server. Sorry, let's come back. Yes, so assume that this another machine sends a request to that same web server, but it's a different machine. So it is sending a request on that machine, same machine, 100.0.0.1, same port number, and assume that the source port number of this machine is different. Source port is 4991. So for that previous machine, the source port was 2311. In this second machine, it is sending a request to the same web server, and this is using a different source port number 4999. There is another machine which is sending a request to a different machine at the outside world. Say the IP address of this machine is 152.95, and this is sending a telnet request. It is sending it wants to do something using telnet, so it is sending a telnet request to this server. So the destination port is 23. Port number 23 is used for telnet, so it is sending using the destination port 23, and say it is using the source port 7575. And then there is one more machine, another machine, and this is sending a request to another server. Say the server address is 200.0.0.1, and say this is a mail server. Assume that this is a mail server, and so it is sending a request to this mail server on port number 495. 495 is sometimes used for encrypted email service. So it is sending a request to this mail server. The destination port is 495, and by chance it is using a source port number 4999, which is similar to this source port number of this other machine. Now because they are separate machines, by chance their source port numbers have become same. Now remember, what does this NAT enable router does? It changes the IP addresses. We have already seen what happens in the static and dynamic NAT. In the same manner, it also changes the source IP. So what does it change? It has changed this source IP from this private IP address to this public IP. Now remember, all of them are mapping to the same public IP. In the previous example, they were mapping to different IPs. Now all of these are mapping to the same IP address. So it simply changes the source IP from 10.0.0.5 to 70.10.0.1. This is the public IP. In the second also, the source IP is changed to the public. The third one also changed to the public, and the fourth one also changed to the public IP address. Now look at this and see if this scheme works. Clear? Now a message from this machine, after changing the source IP, this is the whole structure. The source IP becomes this, source port is whatever the source port number, the destination IP is this, and the destination port is this. Now if you look at all of these, each of them is a separate tuple. That means if I create a table, so each of this table, if I have the source IP address, if I have the source port number, if I have the destination IP address, and I have the destination port number, if you look at it, each of them is unique. See, in this example, the source port by chance becomes same. Okay, so whenever change the source this IP address, the IP address also become public. But remember, something is different. What is different? The original public IP address. So something will be different. So this is my first level of solution. But there is a problem in this. Can you think where a problem can arise? The problem can arise where, assume that these two machines by chance use the same source port. Say this also use the same source port 2311. By chance these two machines use the same source port number. Here they use the same source port number, but this did not create a problem because they were sending a request to different destination. But these two machines are sending requests to the same destination. There is the same destination port, and by chance their source port is also similar. Now whenever this change is made here, look at the first example. In this first example, the source IP becomes the public IP, the source port becomes 2311, the destination IP is that as web server, and this is the destination port. For this second machine, the source IP is also changed to this public IP. Now this source IP is 2311. 2311 because we have taken in this example that by chance this machine also uses this source port number. The destination IP address is the same machine because they are sending requests to the same web server, and the destination port is 80. Now these two become identical. Now these two have become purely identical. Now there is, when the reply comes from this web server, there is no way of distinguishing between these two particular requests. So it does not know whether that particular response is for this machine or for this machine, because these two have become almost identical. Now what solution can you do in this case? So the solution is done by using one another information. So what it does is, apart from changing the source IP address, it also changes the port number. Yeah? So it another extra information in this table. So this is another number. So instead of using this port number, this local source port number, which was from the private IP network, it changes these port numbers to another port numbers as well. It uses the same port number ranges, but it changes this port number from this port number to another port number. So even in this example, in the previous example, if this local source port number by chance becomes same, say we have seen that there may be a possibility that both of these machines sending a request to the same machine, and by chance their source port number also becoming same. In that case, because this intermediate router changes this port number as well, so the source port number is changed from this port number to a different source port number. This source port number is changed from this number to another source port number. So now these two messages can be differentiated. Now they are not identical. So what things have been changed? The things that have been changed is the IP address. First, the IP address is changed from the private IP address to the public IP address, and then the other change is made from the original source port number to a different source port number. Now all of these becomes completely different. None of these tuples will be identical. So using this manner, thousands of private IP addresses can be mapped to a single public IP addresses, and then using this scheme you can save a lot of IP address space. So you can see that I can have many number of private IP addresses, and each of them can map to this single public IP addresses just by using this scheme. So I change the private IP address to the public IP address, and then I change the local source port number to a different source port number. By chance, what if some client uses a port number of a NAT source port number which has been used? Say one more machine, another machine has a uses a port number, say 8000, which this has already used in that source port number. No problem, it will simply use another port number here, say 8050. So there is no problem if a port number used in this side appears in this side as well, because it is obviously changing it. So for this port number it uses under port number. So by using this scheme, this mapping can happen, and this NAT with pad has enabled a good number of private IP addresses to be mapped with a single public IP addresses. So usually this particular mode will assign source port in this range 1025 to 65500. Clear? So you can now see that this NAT with pad mode has helped to preserve many real public IP addresses. I hope this topic of NAT is clear. Now we'll go to another protocol, DHCP, Dynamic Host Configuration Protocol. So this particular protocol, DHCP, is used to assign IP addresses to the host of a network. So we have till now we have been saying that I have this host in my network, and each of these hosts have an IP address. Now who assigns these IP addresses? Say I have both the IP address, or I'm using some private IP addresses, and these computers have this particular IP addresses. But who is assigning that this computer has this IP address, this computer has this IP address, this computer has this IP address? The second question is whether this machine has this IP address, this particular fact is fixed, or this machine has this IP address at today, tomorrow this machine can have a different IP address. What is the scenario? So someone should be there to assign this IP address to these computers. For a smaller networks, a very small network, a particular person or say the network administrator can assign these IP addresses manually. But when the organization is large, it is not possible for someone to visit all these machines and then assign a IP address manually. So this is done dynamically, and this is done by using this protocol called DHCP. So once an organization has got some addresses, some IP addresses, whether they are using public IP address which they have bought, or whether they are using private IP addresses, this IP address need to be assigned to the host and the router interfaces of that particular organization. So this is done by this particular protocol, and this is done automatically. This particular assignment is done automatically using this particular protocol. So IP addresses are assigned on demand. Okay, so this assignment is automatic. This is dynamic. Dynamic means whenever someone requires an IP address is provided. If a particular IP address is available, that particular IP address is provided to a machine on demand whenever it requires. So it is connected to the internet, and because it's connected to the network, it requires an IP address, so an IP address is provided. Now if it cuts from the network, it shuts down this computer and is not connected to the network anymore, obviously it does not require the IP address at that time. So that particular IP address to which it was allocated at the previous time, this IP address becomes free, and that IP address can be assigned to another computer if required. So this assignment is dynamic, and this dynamic assignment of IP address is desirable because it avoids manual IP configuration. Now nobody is required to go to each of these computers, visit them, and then assign manual IP. So this is not more required, and it also supports the mobility of laptops. It also supports the mobility of other mobile devices, small mobile devices which are connected to the internet. So because these mobile laptops or mobiles using Wi-Fi moves around the inside an organization, so it happens that say this is an organization and I have a subnet here, I have a subnet here, I have a subnet here. So if someone is using the Wi-Fi in their mobile, so someone is in this area, so it should be assigned an IP address of this particular subnet. Now if this person moves to this area, now it should be assigned an IP address from this subnet. Clear? So if this happens automatically, then obviously things should be easy. There is no manual intervention. So this particular protocol DHCP is used for this assignment of IP addresses automatically. And this particular protocol DHCP is based on a very popular protocol, a protocol known as BootTP. So BootTP is a predecessor of DHCP. So it almost works like BootTP, but it adds two important things. It adds automatic allocation of reusable network addresses. Reusable means a particular IP address can be reused. So it can be used for one machine, it can be used for some other machine at some other time. And there are other additional configuration options, like subnet mask or some other information. Now this DHCP is a client server protocol. That means there is a client side and there is a server side. Now who is the client and who is the server? The server is the host that allocates the network addresses. That means I have my machine which wants an IP address. Now this is my client. So client is the host that requests these parameters from the server. So this client requests for IP address. So this is the client from where it is requesting. It is requesting this from a server. So this server is allocating the network address to this machine. So the machine which is requesting for the parameters like IP address, subnet mask, they are the clients, and the server who is providing those network address and other parameters, that is the server. Now we'll see how this protocol works. So there are different type of DHCP messages: DHCP discover, DHCP offer, DHCP request, DHCP acknowledge, DHCP decline, DHCP next. So there are different type of messages in DHCP. We'll simply see the flow, how initially an IP address is provided to a host machine. So we'll only concentrate only on 4 of these messages. The rest of this message will not discuss. We'll simply see the main process, how a IP address is allocated, and for this allocation these 4 messages are used one after another. And now we'll see the process. So the first process, the first message is the DHCP discover. Now let's assume that an organization has this machine which we call a DHCP server. Okay, the first is the organization has a machine which is called a DHCP server. Now what this server does, this server is responsible for allocating the IP address. Now from where does it get the IP address? It has gotten block of IP address, whether it is using private IP addresses or whether it has bought some public IP address. So now assume that it has got a block of IP address. Say it has got IP address from 190.168.168.0.1. From this IP address, it has got a range of IP address to 190.168, say a huge number of IP address. Say it has got around 2 to the power 16 minus 2, this number of IP addresses it has got. So it can allocate this different IP address to different machines. Whenever some machines are connected to that network, it allocates an IP address from this pool to this IP address. So say one IP address it has allocated to one machine. Now that IP address goes out from its pool. Now it cannot allocate that IP address to another machine until and unless the previous machine deallocates that IP address from itself. Clear? So it goes on allocating the IP address to machines on demand. Now let's see how does this process works. Now say 4 computers are already connected to the network and each of them has been given an IP address. Clear? Now say a new machine comes to the network and now it has to be allocated an IP address. Now what is the process? Now before going to the process, most of the organization have normally more than one DHCP server. Clear? So normally it happens that this organization has one more DHCP server. It can have more than 2 also. So it has got some block of IP address. So some IP addresses are with this DHCP server and say some other IP addresses are with this server. So this DHCP server will allocate it from a block of IP address. This DHCP server will allocate from another block of IP address. If in an organization there are say many subnets, say there are 5 subnets, it is possible that each of the subnet has got their own DHCP server. Clear? So say in this example, in our organization there are 2 DHCP server. Some IP addresses are with this DHCP server, some IP addresses are with this DHCP server. So they are equally divided. Now a new machine comes to this network, and because it wants to access the network, it has to have an IP address. When a new machine comes to the network, obviously it will not have an IP address. So it is the duty of one of this DHCP server to allocate an IP address. Now how does it happen? The first task of a newly arriving host is to find a DHCP server from where it can get an IP address. So it has to find a DHCP server. So now assume that this obviously, because these DHCP server machines themselves, they have their own IP addresses. So it has to request from these machines. But how it will know the IP address of this machine? It has just arrived in the network. It has just connected to the network. It requires an IP address. From where it will get an IP address? It will get from these DHCP servers. So it has to send a request to these DHCP servers. To send request to the DHCP server, it should know the IP addresses of this DHCP server, but it is new to the network. How does it know this is the IP address of the DHCP server? So what it does, it is done using a DHCP discover message. What it does, it creates a packet and then it broadcasts the packet to all. That means this particular message will go to all the machines in the network. So what is the broadcast address? We already know that the broadcast address is 255.255.255.255. This is the broadcast address of a network. So when I use this destination IP address, that means that particular packet is going to all. Clear? So it creates a message, and this message is known as DHCP discover message. What is trying to do? It is trying to find a DHCP server who it can allocate a IP address. Now when one is sending a message, remember, it also requires a source IP address. We have seen the header. It has a source IP address and it has a destination IP address. Now this destination IP address is this broadcast address. It has to put something in the source IP address also, but it has not got any IP address because it wants an IP address. Because it has got no IP address, it will use the source IP address as 0000. Remember, this is an unroutable IP address. This means that I have no IP address currently. So I'm using 0000 and I'm sending a DHCP discover message to all the machines of the network saying that whoever is a DHCP server, please read this message and provide me an IP address. So the basic task of a DHCP discover message is that it is sent by a new machine on the network. A broadcast message is sent to all the machines. It is basically looking for a DHCP server. Clear? So the first message is a DHCP discover message. Now this message arrives at all the machines including this DHCP server. So in our example, there are two DHCP servers. All machines will receive this message. Others will they will discard this. These two DHCP servers will accept this message and then see that someone is looking for a IP address. Okay, now in this original DHCP discover message, there is some ID also, some transaction ID. Some ID is a particular unique number is sent, which is known as transaction ID for this particular message. Now the second message is a DHCP offer. Now the DHCP offer is a message which is sent from the DHCP server to the client machine. In the original one, a message comes from the client machine to the DHCP servers through a broadcast message. Now the DHCP server receives that original DHCP discover message and now it has to offer the IP address. So in our example, there are two DHCP servers. Now both the DHCP servers send their offers. So I have two DHCP servers in my example. So one DHCP server sends one offer from its pool of IP address saying that I am offering you this IP address with this subnet mask for this particular amount of time. So it offers a proposed IP address, it offers the network marks, and it offers a lease time. Every IP address is provided for a particular lease time. After that amount of time, that offer is over, so it has that particular client has to ask for another IP address, or it has to extend the validity of the IP address. Now because there are two DHCP servers, the other DHCP servers also send the offer. So now the second message is a DHCP offer. This goes from the DHCP servers. Okay, so if there are multiple DHCP servers, there can be multiple offers. Now remember, this DHCP server is also a broadcast message. That means the destination IP address is still a broadcast message, because that machine, that client machine, has got no IP address as of now. It is requesting for an IP address. If that has got an IP address, then this particular DHCP server could have sent a message to that particular machine. Now because that particular machine does not have an IP address as of now, so this DHCP offer message should also be a broadcast message. This will go to all. But remember, this message will contain the transaction ID, the original transaction ID of the original DHCP discover message. Whenever there was a DHCP discover message, there was a transaction ID. The same transaction ID is used in the DHCP offer also. So this message goes to all the machines, and other machine will discard. The only machine who will accept the DHCP offer message would be the new client. It will simply look at the message, it will see the transaction ID, it knows that this is in response to the request it has sent. So now it will read the DHCP offer. Now it has got an offer from two machines. Clear? Now it can select any one of them. So say it accepts the offer from this machine. Okay, so the third message is something known as a formal DHCP request message. Now once the machine receives proposal, so in this example it has received a proposal from these two machines and say it has decided to accept the offer from this machine. Now it will send a formal DHCP request to this machine saying that I have accepted a proposal, I have accepted your proposal for this particular IP address. Now I am sending my request my formal request for this IP address. Clear? Now this request, DHCP request, is also a broadcast message. Now remember, when it sent an offer from this machine, when this DHCP server sent this offer to this machine, it had sent its IP address also, the source IP address of this machine. So this could have sent this message to only this DHCP server. But why does it send a broadcast message again? It sends a broadcast message again because the other machine should also know, this other machine, the other DHCP server should know that it has decided to receive the offer from the other machine, not my machine, so that now it can allocate its offering to some other machine. Clear? So this DHCP request machine is also a broadcast message. So first is the discover message to looking for a DHCP server. The next is a offer message, the DHCP server offering IP address to the machine. Then third is the DHCP request message, the formal request for that particular IP address. And then the final message is the DHCP acknowledgement message. This is finally sent by the DHCP server to that particular client machine saying that I have got your request. Now this is finalized. So I'm acknowledging that that particular IP address has been allocated to you. Now you can use that IP address. From that point onwards, that particular machine can use that IP address. Now because this is a dynamic protocol, it can continue using this IP address until the machine shuts down itself or the lease period of that IP address is over. If the lease period is over, it now simply required to request for extension of time, or you can request for an allocation of any IP address. So this is the process of allocating an IP address. So this finishes our discussion on NAT and DHCP. I hope the concepts are clear, because both of these concepts, NAT and DHCP, are important concepts in networking. In the next lecture, we'll discuss about IPv6 header. Thank you.